Hello everyone, in this video we are going to see about the simplification of Boolean algebra. We have a method called Karnaugh map method. Let us see in detail in the following slides. Let us see first of all what is Boolean algebra or a Boolean function. A Boolean function consists of binary variables and the logical operations. The algebraic expression is known as Boolean expression and it is used to describe the Boolean function. The Boolean expression consists of the constant value 1 and 0, logical operation symbols, and the binary variables. That means here the expression may contain a variable, logical symbol as well as the values with the constant values 1 and 0. Let us see a few examples of these Boolean functions or Boolean expressions. F is equal to x, y bar z plus p. Here f is the function of four variables x, y, z and p, and y is in the complement form. The value of the variable in the complement form is 0 and the normal form is 1. Next expression, f is equal to a, b, c, d. This way also we can mention the function with the variables included. So f is equal to a plus b, c bar plus d. That means here a, B, C, D are the variable and C is in the complement form. Another example, f of A, B, C, D is equal to A bar, C bar plus A, B, C, D bar plus B bar, C bar, D plus B, C, D bar plus A bar, B bar. So that means here the variables A, B, C, D may be either in the combination of same as well as the complement form. That means the normal form as well as the complement form. Here somewhere the A is in the A bar or the A dash and somewhere it is in the normal form. So it can be in the both the normal form and the complement form. Let us see what is the Karnaugh map. The Karnaugh map, also called as K map, is a graphical representation. It provides a systematic method for simplifying the Boolean expression. Actually, we have normally when we use this mathematical expression, we have some method to simplify the equation. Same way the Boolean expressions also need to be simplified. What is the necessity of simplification is, if the simplification is done, we can implement the Boolean expression using minimum number of gates. So that will minimize the burden of the particular the component as well as the speed will be increased. When you design a circuit with the Boolean expressions implemented, there we can see this difference. The K-map method is used for expressions containing 2, 3, 4 and 5 variables. That means we can have the K-map method for 2 variables, 3 variables, 4 and 5 variables. Beyond that, we cannot use the Karnaugh map. For that case, we are using the Quine-Mikulski method. This method is the tabulation method. This method helps to solve the simplification of Boolean expression when there are high number of variables. Based on the number of variables in the Boolean expression, the K-map is defined. Let us see about, in this video we will see about the 2 variable K-map, 3 variable K-map and the 4 variable K-map. Let us see first how the map looks like. In K-map, the number of cells is similar to the total number of variable input combinations. So we know that when you have 2 variables, we have the components or the combination is about the 2 power n. Let us see, if the number of variables is 3, then the number of cells is 2 power 3, that is equal to 8. That means for 3 it is 2 power 3 and for 4 it is 2 power 4 is equal to 16. So this decides the number of cells in the Karnaugh map. The K-map takes the SOP and the POS forms. Actually, SOP is sum of the products and PO is the product of sums. You can use that either SOP or POS. SOP is also called as min terms and POS is also called as max terms. The K-map grid is filled using zeros and ones. The K-map is all solved by making the groups. Okay, now let us see how the K-map looks like. And before that, we'll see what are the steps to solve the expression using K-map. The first step is we find the K-map as per the number of variables. First of all, we have to find out how many variables are there in the equation. Accordingly, we have to design the map. It may be a 2 variable map, 3 variable map, or a 4 variable map, or a 5 variable map. Find the max term and the min term in the given expression. The given expression consists of the components added. That means the products are added to get the sums. So that is the max term and the min term. So you have to find out whether there may be the presence of max term or min term. You have to find out those terms in the given expression. Next step is fill cells of the K-map for SOP with 1 respect to the min terms. And fill cells of the block for POS with 0 respective to the max. So that means when there are min terms, you have to use the value 1. When there are max terms, you have to use the value 0. This is the way you have to fill the K-map. Next, we have to create rectangular groups that contain total terms in the power of 2, like 2, 4, 8, and try to cover as many as elements as we can in one group. Actually, what does it mean is we have to connect the adjacent ones available in the map. That is called grouping. So that group may be number of 2 ones, it may be 4 ones or 8 ones, etc. But those cells should be in the continuous locations. They should be in the adjacent locations. Then only they can be grouped. When you group those locations, we can be able to solve the expression. With the help of these groups, we find the product terms and sum them up for the SOP form. So here are the simple steps. Let us see how the K-map looks like. This is the 2 variable K-map. As you know that for 2 variable we have 2 power 2 combinations, which is 4. So we can see here 1, 2, 3, 4 starting from M0 to M3. So in 2 variable K-map we have 4 cells. They are named as M0, M1, M2 and M3, and the cell may be arranged either this way or this way. Both are same. Okay, so here only the values are mentioned exactly. So the location, the arrangement may be same, but the values remain the same. Okay, that means the arrangement may be different, but the values remain the same. Okay, so now how to name these variables and how to put this value. So this map consists of 2 variables, y and z. So write the 2 variables like this. Now we know that the Boolean values or variables can take the value either 0 or 1. Same way, here the y is another variable. It may take the value 0 or 1. So you have to write the values this way. So 0, 1 and 0, 1. Now this combination says that when y is 0, x may be 0. When y is 0, x may be 1. Likewise, when y is 1, z may be 0, and when y is 1, z may be 1. So the combination may be 0, 0, 0, 1, 1, 0 or 1, 1. So that is what written in another form like this. Here 0, 0, 0, 1, 1, 1, 1, 0. Actually, here we have a rule in naming these cells. Actually, what is the rule is the successive terms should differ by only one position. For example, here we can see 0, 0, 0, 1. Here these two consecutive numbers differ by one position. That means only this LSB is different, other number is same. And now compare these two values. Now the value is 1, 1. Here in LSB that is 1. So they are same, but they are different in the MSB. 0 and 1. So they are differing in the MSB position. Here in between these two they differ in the LSB position. We know that LSB is the least significant bit and MSB is the most significant bit. And now compare this value and this value. Here this one and this one are same, but the LSB, this is 1 and this is 0. So each successive value should differ in only one position. That is the property of the Karnaugh map. Okay, now this is the way we have to arrange the values. Then from the equation we have to pick up the values and fill the cell as 0 or 1. If the combination is present in the cell, we have to put as 1. If the combination is not present, we have to put as 0. For example, if we have the combination YZ. Okay, so YZ means here we know that when it is 0 it is in the complement form, when it is 1 it is in the normal form. Suppose if the equation contains f is equal to yz, that means y is 1 and z is 1, so this is the combination, 1 1 is the combination. Let us see in the coming videos how to fill the values and solve the equation. For now let us see, just let us know how the map looks like. Next, about the 3 variable Karnaugh map. Here we can see, as we know that 3 variable consist of, when you have 3 variables, you have 2 power 3 combinations, 8 combinations, 1, 2, 3, 4, 5, 6, 7 and 8. So 8 combinations for 3 variables. So how to name the map? So write 2 variables together as A, B and another one as C as separately. Okay, and now for this AB, the combinations may be 0 0, that means A may be 0 and B may be 0, and when A is 0 B may be 1, and A is 1 B is also 1, and when A is 1 B may be 0. That means the combinations are 0 0, 0 1, 1 1 and 1 0. Same way this C can have the value either 0 or 1. Okay, now this is the vertical name and this is the horizontal naming of this map. Now how to make the combination is, for example, if you want to represent 0 0 0, that means A is 0, B is 0 as well as C is 0, that means 0 0 0. This is the cell which says that 0 0 0. We know that when the value is 0, the variable is in the complement form. When the value is 1, the variable is in the normal form. Now we can see in this cell A, B, C all three are in the complement form. So the cell value is A bar, B bar, C bar. All the 3 variables are 0. Okay. So this is how the, so when in this equation, in the Boolean expression, when these terms come, we have to put 1 in this position. Okay. Suppose if the equation contains A, B, C, we have to put 1 in this position. Remaining position should be filled with 0. Okay. For example, if equation contains f is equal to A bar, B, C bar and ABC, means this cell alone should contain the value 1, remaining will be the 0 values. Okay, so likewise we have to fill in all the values. Now say for example, take this position. Okay, see here A and B in the normal form and C is in the bar form, which is the complement form. So here the cell position is, cell content is A, B, C bar. Okay, A, B, C bar. If you take this location, how it happens? This is 1 0. That means A is in the normal form, B is in the complement form. So A, B bar, and in this position C is in the normal form. So A, B bar, C. This is the content of this location. So this is how we have to name the variable in the Karnaugh map. So now how to, for this we should be thorough with the binary equivalent of basic numbers from 0 to 15. That will be helpful to fill these values very easily. Now let us see about the next one, 4 variable Karnaugh map. As the name implies, we have 4 variables A, B, C, D and we have 2 power 4 combinations, which is 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 combinations are there. They are numbered from 0 to 15. Okay, so the same way we have seen in the previous variable 3 variable map. Suppose if I want to mention this location, okay, so this is 0 1 and this is 1 1. That means 0 1 means A is in the bar form, B is in the normal form. So A bar B for this one. Then for this vertical position A B, that is C D. So C and D in the normal form. Then that means here for this content, for this location, the value will be A bar B and then C D. So you can see here A bar B and C D. This is the value of this particular cell. Suppose if I want to fill this location, you assume. So 1 0 and 1 0. So what is 1? What is 0? A is 1 and B is 0. That means A B bar, because we know that bar, when it comes the value 0, that is in the bar format. And for here C D bar, because this 1 0, C is in 1 form and D is in the C is in the bar form. So A B bar, C D bar. So here this is the content. Okay, likewise you have to fill in all the variables. Now when in our Boolean expression, suppose these terms comes A bar, B bar, C D and A B C D, means only these position will have 1 as the value, remaining all will be that 0. That means the presence of any min term, this is called as a min term. Okay, this is called as a min term, and we are going to write the sum of the product terms, which is SOP. So we have to combine the min terms, or we have to sum of the min terms to get the sum of the products. Here are the products. You know that this is A bar into B bar into C bar into D bar. This is one product A, B, C, D. This is one product A, B bar, C, D. So all the cells are the product forms, and the equation consists of sum of these terms, which is the min terms. So that's all the basic concept of how the 2 variable, 3 variable and the 4 variable Karnaugh map looks like, and how to fill in the cell values. Let us see in the coming videos how to fill in the values with respect to the problem given, and how to simplify the Boolean expression. Hope this is the basic concept of Karnaugh map is easy to follow, and thanks for watching.